Welcome to Luca is a Billionaire, where the only thing I invest in is your answers.
You begin by confirming the model is ready. Check for duplicate nodes, tiny edges, and non-manifold faces so the mesh won't fail later. Next, pick element type and units, shell versus solid, versus inch, and set a seed size target that matches analysis needs. Once done, assign component ID and enable auto-heal checks so Hypermesh can fix minor defects automatically. This reduces manual cleanup and lets you start the actual meshing process immediately. You now refine control parameters and apply targeted mesh operations. First, adjust seed size per region and use size maps or refinement boxes to concentrate elements where stress gradients are high. Then enable mesh controls, curvature-based refinement, proximity limits, gap filling, and smoothing, so the solve-ready mesh respects geometry and load paths. After that, run local meshing commands, generate quads on mid-surfaces, recalculate normals, collapse tiny edges, and inspect aspect ratios. This sequence balances quality and element count effectively. You finish by running global quality checks, aspect ratio, skew, Jacobian values, so the mesh meets solver requirements. Once validated, export to the solver and run a brief convergence or stiffness check to detect weak regions. If something goes wrong, isolate the problematic area, reduce seed size or change element type there, and remesh just that patch. Alternatively, use local patch and smoothing tools. Make sure to rerun quality checks after fixes so you don't reintroduce errors.
Thanks for watching and please subscribe. It's the best investment you'll ever make.